Hello, class, receiving students and teachers. Thank you. Take your seats. Receiving students and the model class, we will now go on to recapping on what we have done in our last lesson. In our last lesson, you made models of particles according to their different states, and we briefly looked at their properties. I am now going to show you on the screen some properties of the different states of matter, and you will tell me whether those properties match those different states, which is solid, liquid, and gas. Okay, let's have a look at the first one. Okay, I'll allow you to quietly read, and I'd like you to guess. Quietly read, meaning in your minds. Receiving students, please tell your teacher. All right, who is ready with the answer? You either guess, you will tell me whether this property match solid, liquid, or gas. Okay, who's ready? Model class, receiving students, tell your teacher. Does these properties belong to gas, liquid, or solid? Do not look into your books. Thank you. We have a hand up there. Give us your answer.
Solid.
All right. Thank you. Good try. Leon? Particles further apart from each other.
Liquid.
Right, liquid. Thank you. Good try. Okay, those of you putting your hands up, what do you think? Yes. All right, good. These properties belong to gas. Particles are further apart from each other, and they fill whatever container it is in. Attraction is weak and lots of space between them, meaning from one particle to another there is big space, okay, between the particles, and free to move in any direction. Now let's go on to the next one. Class, reading. Receiving students, I hope you're telling your teacher. Cullen, what do you think?
Solid.
Class, you agree with him? Yes. Okay, receiving students, good on you if you have said solid. Particles are arranged in order and very close together, fixed shape and volume, and they have strong attractive forces holding them together. All right, class, the last one. What do you think? All right, those of you putting your hands up together with the receiving students? Liquid, right? Liquid takes up the shape of the container, and they are slightly close to each other, but not very close, and they do not have very strong attractive forces like solid particles. Teachers, we are now on the same strand, science in the home, sub-strand, learning about substances. Our outcome is 7.3.1. Let's see what our topic for today is like. Class, let's read the topic together. Okay. How do you understand that topic? What are we going to do? What is the key word in that topic? Models, okay. Some of you say models. States, okay. You can have maybe two keywords, which is changes or change of state. Right. When we say change of state, we are meaning we change solid to liquid to gas. All right. First of all, we are going to, before we carry out our experiment, we are going to do predictions. And this time you're not going to write, but you are going to draw. So let's have a look at our instruction for this quick exercise on making predictions. Okay, class, looking on the screen, draw a line to predict how the temperature will change ice, which is in its solid states. Remember, water comes in three states. It can be in solid state, it can be in liquid state, and it can be in gas state. So what you are going to do, you will, in your workbook or exercise book, you will draw a line to predict how the temperature will change ice from solid to liquid to gas when heat is applied, or when we give heat to change the states of those three things. Okay, I'll start you off here because we are going to talk about heat and temperature. Now let's imagine that we have ice. You just draw a line. If you think that temperature won't change, now that let's start from here with this dot. If you think that temperature won't change when we are heating ice, then you draw your line like this. If you think that temperature will change when we are heating ice, then you draw. If you think that temperature will change, go up, temperature will go up when we are heating ice, then it will go straight again, it will be steady, then it will drop, then you draw that. Your own idea, what is going to happen when we heat ice? How is it, how will the temperature change? You just indicate by just drawing lines only. And at the end of the lesson, you will understand what you have drawn, or we will make comparison. I'm not asking you to give me correct answer, you guess, you are only guessing. So don't be upset or thinking very hard. This is part of science, we are learning science, we go through predicting. So receiving students, your teacher will help you, or you can go by what I've given to you as an example. Just a rough drawing to predict what will happen to ice when it changes from solid to liquid to gas when heated. We are going to be heating ice. Okay, heating means we will try to melt it now. How will the temperature change? Will it go up, or down, or straight? You guess. Nothing hard, just guess. All right, well, let's see who has finished guessing. Okay, guess. Okay. All right, how will the temperature change? Now that imagine we have ice now, we are going to heat it up. We are going down. You can discuss among your group members, and your group members can put their ideas together to help your group. If you want to work individually, you can do so. Don't think that, don't be afraid of getting it right. Okay, you guess. So don't feel scared of drawing that line. Don't be afraid of making mistakes. We all learn from our mistakes. And this is only guessing. I'm not looking for correct answers at this point in time. Okay, finish. All right, thank you. All right, the last one group to come up and draw their line. The others, you keep whatever line that you have drawn. You have a look at it and just compare your lines with this group that will come up and draw their lines. Let's have Donald's group. Thank you. This is what Donald's group think. Thank you, Donald's group. Clement's hand is up. He'd like to show his group's work on the board. Okay. Say, rewrite Donald here. Okay, Win. Thank you. Good. Class, give them 2 big claps. Yeah, I'm not saying you are clapping for them because they are right, for their effort, and you also for making an effort in drawing your lines. Please do not erase those lines. Leave them as they are, and we will now go on to our experiment to confirm our predictions. All right. This is what I'd like you to do now in your exercise book. Receiving students and teachers plus the model class, the activity in the workbook is going to be slightly different in today's lesson, meaning I am not going to use the activity that is in your workbooks or in the teacher's resource book. We are going to do another activity, however, it will have the same concept as the lesson being written. So please, I'd like you to quickly copy this result table into your exercise book. You should have time, temperature, and time 1 to the 10th minute. No need to draw these lines across. You already have lines in your exercise book. So you only draw a big square like that and include the times. All right, I hope you all have finished copying the table down, receiving students and the model class. This experiment I am going to demonstrate for the model class. Receiving students, if you have your materials ready and you are going to be working in groups, that's okay. If not, you will have to follow the model class with me. Now, we will go through the materials that we need for this experiment. The materials needed are ice cubes, banners, beakers, gauge, thermometers, tripod stand, retort stand, steering rod, and watch. Okay, looking up here, where I am, you will see which one is, somebody to tell me which is a steering rod. Looking at the setup I have here. Steering rod. Find it here. Which one is it? Okay, let's have this student here to tell us. Use the mic. And go and point to it or lift it up and show it to the class. Steering rod. Okay? No. Okay, that's what she thinks. Is that the steering rod? I'm sorry, answer is wrong. Okay, somebody here, please come up and show the class. Is she correct? Yes. Okay, that is the steering rod. Okay, we have the steering rod. What do we call this, class? Okay, it's a stopwatch. This one here? This wire. Okay. Gauge. Okay, this is known as the gauge. What do we call this bottle here? Banner. All right. We have a banner here. And what is on the... Okay, this is a tripod stand. And this one here with blue, retort stand. Okay, this is a retort stand. All right. All right. So I will now set up the things needed for this experiment. That is the banner. The banner is already beneath the tripod stand with the gauge. Then we have the ice cube with little water on the tripod stand. So this is my setup. All right, I am now going to gently stir. Class, you must watch carefully. Okay, the temperature at start with ice and water in the beaker is 0.9 degrees Celsius. That was the reading at start. Okay. Now I am going to light the banner and start timing. You will take the reading of the temperature every 1 minute. .5 degrees for the first minute. 4.5 second minute. Eight point nine, third minute. Has all the ice melted? Fifteen point two. 15.2. Twenty-six point zero. 26.0. That is 6.1. 0.1. 45.9. Fifty-four point eight. 54.8. That's for the 8-minute. Sixty-two point three. $70.1 degrees for the 10th minute. Okay. You can see steam rising now from the beaker. That means the water is now changing into gas. Okay, we will now stop here. Class, I'd like you to look at all the readings that you have recorded with your desk mates and try to see whether you are correct or you have missed out on All right, we will now confirm our predictions by looking at what we have collected in the experiment that we have done, your table that you have completed. Let's now look at Donald and Wynn's diagram, their drawing of the graph. Now, can someone come up and quickly draw how the graph or the line would look like if you are told to draw a line graph? Using that information, using the table, how would the graph look like? How would it look like? Thank you, Shannon. look at the change of temperature. All right, thank you. Let's have a look at yours. Beckley. But Beckley, can you tell the class why you have it like this? Why you have your line drawn that way? Just by looking at what information you have collected. Why do you have it going up straight and then straight, flat, and then up again? All right?
Because the ice, when we take the reading of the ice went up and stopped. And when the banner was on fire,
All right, thank you. Thank you, Beckley. I know what you're trying to get at. Now, class, which one do you like, the first one or the second one? Hands up if you go for the first one, which is, okay, good. Hands up if you go for the second one. No, and hands up if you have a different one altogether, apart from these two. Okay, good. Now, if I can explain this one here, this one says, as soon as I place, this is before heating. I think, is that what you mean? Before me lighting the burner, as soon as the thermometer was put into the ice, you found out that the temperature was dropping. Was that true? Yeah, the temperature was dropping, and it went to 2.9 yeah, 2.9 degrees. And when I start heating, when there was flame now, what happened to the temperature? It was beginning to rise, and it was going up gradually. Okay, that's how I can explain how the temperature changed from that group's idea. Maybe Beckley here thinks that when we started heating, the temperature rose, and what happened? It did not rise anymore, it was just steady. Maybe it was just at 21, 21, 21, 21. I'm just giving an example. Then when it came up here, it rose again up. Right. So I hope you understand what I am trying to get at, or what I am trying to explain to you, how temperature changes when heat is applied. Now we will go on to some questions. You are going to draw a graph using the result table, and you will compare. The graph will look like this. You will have temperature and the time. This time you won't do a rough drawing. Now you will use a graph to plot your results. You'll do that for homework. So just copy the graph down, and that will be done for homework. The horizontal axis will show the time, and the vertical axis will show the temperature. And you will complete that for homework. Okay. I just stopped with 40. You can continue up. 40, 50, 60, 70. So as the time I stopped at 4, you continue to 5, 6, 7. We had 10 minutes, so you should have numbers from 1 to 10 for time. All right, you'll do that for homework. Let's move on to our summary for today's activity. Receiving teachers, you're encouraged to develop questions out of the graph, and I will do that for the model class during your non-TV time. You will be given questions out of the graph. All right. Our summary point for today: change of state occurs or happens when heat is applied or removed. Class, I hope you have copied the summary down nicely. Thank you so much. Let's move on to our key phrase for today: change of states. Our next lesson will be on physical changes in our environment. Materials needed: pencils and workbook. The next lesson we are going to go outside and do our observations, and that will be on a new on a new outcome. With that, thank you class for your participation in today's lesson.